Today we will discuss a problem based on parabolic arch. And this lecture we will also discuss how to draw the bending moment diagram for this parabolic arch. So please write down the question. A 3-hinged parabolic arch of span 25 meter and a central rise of 5 meter carries a point load of 15 kilonewton at 6 meter from the left hand support. First, find the reaction at the supports A and B. And the second question, draw the bending moment diagram for the arch and indicate the position of maximum bending moment. So I hope all of you have write down the question. So now we'll move on to the problem, how to solve this question. So a 3-hinged arch is given here with A and B as the supports and C as our crown point. And 15 kilonewton is acting at a distance 6 meter from the support A. Then we can choose this point as capital D, and the total length of the span is 25 meter. In our question, we have to find out what are the reactions VA, then VB, horizontal thrust, then what is the resultant. Then we have to find out the bending moment at this particular point D. Then the question is asked to find out the maximum bending moment and also both positive and negative, and we have to draw the diagram also. So if you take the point sigma MA equal to 0, we already know that both A and B, the sigma MA and the sigma MB equal to 0. So if you take this MA equal to 0, so here minus VB, that is it is in anti-clockwise direction, multiplied by 25 span plus 15 means this load and this acting in the clockwise direction 15 into 6, and finally you will get VB equal to 3.6. After getting VB, if you add VA plus VB equal to 15, and you will finally get the value as VA equal to 11.4. Then we have to find out the horizontal thrust. For that we will either take LHS or RHS. So in this case we will consider the RHS side. So we will get the value as minus VB, which is in anti-clockwise direction, and H it is clockwise direction, and H multiplied by this distance. So finally you will get H equal to 9 kilonewton. Then if you take the resultant, you will finally get RA and RB respectively. Then coming to the value, that means the YD value. YD means the vertical distance. Vertical value will be this parabolic equation 4hx multiplied by L minus x divided by L square. If you substitute the corresponding values, that means H equals 5 meter, X equals 6 meter, and L equals 25, you will finally get 3.648. And we know that bending moment at D. If you want to find out the bending moment at D, we have to multiply what is the vertical force at the A into 6, that is the horizontal distance, then H into 3.648 that we obtained this here. So finally you will get the 35.57 kilonewton, that is the maximum bending moment. So in the previous lecture we already mentioned that if some loads are acting over a arch, we have to convert them into a beam, equivalent beam. So here please note down that the beam moment equals 68.4. That means the total value, if this 15 kilonewton is acting over the beam, if you convert them into a beam, then the value will obtain as 68.4. Okay. Then we have to find out the HY value. If you find out the HY value means this is the value actually. So H multiplied by 3.648, you will finally get 32.832. So for drawing this diagram, first of all you have to draw this 68.4 coordinate diagram. So this point value is 68.4. After that you have to draw the arch. Okay, that is HY diagram. After that only you have to draw the HY diagram. And the value obtained at this much height you will get the value as 32.832. And full ordinate value will be 68.4. And the bending moment at D value is going to be, if you subtract 68.4 minus 32.832, you will get get the value as 35.57. Likewise, you will get the positive value. So that is the case of positive bending moment. Then we have to find out the negative bending moment. So it is going to happen in the RHS side in this case. So we will consider a point. Let us take some distance x from this point B. So y equal to 4 yc into x into L minus x by L square. This yc or h you can write down. That is ground distance. So if you substitute the values, there is two unknowns, that is y is also unknown and x is also unknown. So we will move on to the next step, that is we have to find out, let us take this point BE, let us consider this point BE. So the mx value will be BB multiplied by ax minus h into y. So if you substitute, you will get an equation like the terms of x, since we don't know the value of this distance. So our first intention is to find out the value. So if the bending moment is maximum, then for calculating maximum value, if you take the differentiation, then the value, if you substitute here, if you take the derivative, then the value of x you will get as 6.25 meters from this point B. Okay. So if you substitute this x value here, then you will get the vertical distance also here, that is 3.5 meters. Okay, the vertical distance of this corresponding point. Okay, this is actually BMT diagram. Okay. So if you substitute the value or here in this equation, maximum negative bending moment you will obtain as minus 11.25 kN meter. So that is this value. Okay, you subtract this value, you are going to get, that means BB multiplied by 6.25 will give the beam moment minus this h into y. So the final value obtained here is the positive bending moment value is 35.57 and the negative bending moment value is 11.25. So this is the case related to this problem. So I hope the section is very clear for you. With this we will wind up today's section. Thank you.